Welcome to the Met Office Climate Podcast. I'm Dr. Doug McNeall. Today, we're discussing one of the most crucial, ambitious, and even perhaps ambiguous numbers in climate change science and policy: 1.5 degrees Celsius. There's an increasing urgency to take global action that would limit global warming to 1.5 degrees above pre-industrial levels. But why 1.5? Can we hit that target? And what does it mean if we don't? Today, we're going to explore the science behind this critical target and why it's so essential for our planet's future. Joining us today to shed light on the challenges we face is Dr. Matt Palmer, leading climate scientist and the architect of the new 1.5 dashboard, a groundbreaking tool that provides real-time insights into the status of our efforts to keep warming below 1.5 degrees. Matt leads the Marine Observations and Climate Monitoring team here at the Met Office Hadley Centre. He's also an associate professor at the University of Bristol. Matt was a lead author on the latest IPCC climate change report. Could you give us just a couple of minutes on your Met Office career, how long you've been working at the Met Office?
I joined the Met Office in 2005, but I joined the Marine Observations team back then to look at ocean heat content change. From there, I moved more into ocean modelling and then eventually to work on sea level rise. But then recently I moved back into climate monitoring. And actually, you mentioned the IPCC climate report. And actually, most of my work for that report was on observed climate change, particularly ocean climate and sea level rise.
Can you help us understand what the 1.5 degrees C target is and maybe how far off we are? What is our progress against that target?
Sure. So back in 2015, there was a meeting in Paris. The meeting was really this landmark moment when the international community managed to reach agreement on efforts to systematically limit climate change. And the way that they did that was to come up with a temperature target. In fact, there are a couple of different targets, but we're focusing on the 1.5 degrees C. And really that just acknowledged that it's scientifically well understood that the impacts and the damages and costs associated with climate change and climate risk really start to increase with warming. And so that was the kind of political framework that was constructed to try to limit that warming through systematic reductions in greenhouse gas emissions.
So this is a political target as much as a sort of scientific and observational target.
To my mind, it's both a political and a scientific target to some extent. It's a political target that's been agreed, but it's been informed by the science. We know, and there's been reports commissioned through the Intergovernmental Panel on Climate Change to look at how the impacts of climate change get worse above 1.5 degrees C. And there's clear evidence that the impacts and the damages and the risks all increase beyond 1.5 degrees C. As I say, it's a political agreement that's backed up by science. In terms of how we're doing relative to that target, that's a really hot topic right now. We know that we're well past 1 degree of warming and we're well on our way to 1.5. So I guess there's a lot of interest now, particularly on the surface temperature record. So that's our knowledge of how Earth's average surface temperature has changed over time and is key to the 1.5 target. We know that we're starting to get pretty close. And in fact, the media has been very active in recent times thinking about when we might exceed 1.5 degrees C.
I know as a scientist who's active on social media, I often get asked about this threshold and if this year in particular is going to be over 1.5 degrees C. I know that this is a scientific challenge to really understand where we are in terms of our progress towards that. Maybe we could just talk through some of the uncertainties when it comes to measuring 1.5 degrees C and how close we are to that threshold. For example, I know that 1.5 degrees C doesn't mean, oh, well, if we go over 1.5 degrees C as a global mean temperature for one day this year, as we've heard in social media recently, that doesn't mean we've passed the threshold. That's just one day. And actually, we're talking about a longer term average. So can you talk about some of the scientific challenges?
You're absolutely right. What we haven't really articulated yet is that the 1.5 C target is a long-term warming target. So it's really designed to be a climate target rather than a daily or yearly value. One of the interesting things is that there is actually no formally agreed way to measure progress against 1.5 degrees C. And actually, there's a paper just out from Richard Betts at the Met Office, which really articulates the need to formalize what that measurement is and reach an international agreement in how we measure that. That said, the way that the Intergovernmental Panel on Climate Change, so the IPCC, looks at warming levels, long-term averages of Earth's surface temperature, is to construct these 20-year averages or even 30-year kind of averages. So long-time averages that kind of get rid of some of the weather and year-to-year noise that can, as you say, temporarily maybe push us through a particular temperature threshold.
So, what kind of observations are we taking in order to know that the Earth is on the way to this target? How do we know what the global mean temperature is anyway?
In terms of the IPCC assessments, that's based on the observational records, which are land surface station data. Many of them date back for 100 or more years. So that's why we have this global surface temperature record going all the way back to 1850, and for some estimates, even further than that. So this is really coming from thermometers over time and kind of taking the available information we have and accounting for uncertainties in the distribution, because as you can imagine, they're not equally spaced around the world. So I'm thinking so far mostly about the land surface temperatures. Obviously, the larger part of the Earth's surface is actually the sea surface. So 2/3 of it is sea surface. So it's a combination of looking at how the surface temperatures of the ocean have warmed, and there are measurements dating back from ships and then more recently drifters, etc., and combining that with our knowledge of the land surface temperature change. And then all that information is aggregated together and gives us typically a single number for any given year. So an annual average is often the way that we look at this stuff relative to a pre-industrial period. And that's usually taken as the average conditions between 1850 and 1900. So that proxy for pre-industrial.
And that's the kind of time when we started taking these observations systematically.
Correct. So that's, although there are some science projects looking to push that record even further back in time, as it stands currently today, this kind of state-of-the-art science is to use this 1850 to 1900 period as the benchmark, and that's the standard period used by the IPCC.
So we know that climate has changed a lot since the pre-industrial period that you just described. So roughly how much warming has happened in the last 150 years or so?
Since 1850, we know that the planet has warmed by more than 1 degree. The average of any given year will tend to fluctuate a bit due to well understood climate cycles such as the El Nino Southern Oscillation, or ENSO as it's often referred to. But broadly speaking, we're a bit over 1 degree C. It's looking like the average temperature for 2023 will be somewhere in the region of 1.3 or 1.4 degrees C. That obviously feels very close to this 1.5 degree target.
Yeah, that really does feel like it's getting uncomfortably close, I would say, even though we define, as you say, that 1.5 degree target over a period of years. So does this give us a rough idea about how long it might take to breach that 1.5 degrees C if the Earth is going to go through that target? And is that inevitable? Is there anything that we can do to not breach that target, or is it baked into climate change now?
As we've discussed, we're very close to 1.5 degrees C already, within a few tenths of a degree. If we take a 10 or 20-year average of the last 10 or 20 years, then we're well above 1 degree. We know that the scale of the challenge gets harder with every successive year that the emissions go up. And so really we're looking at needing extremely, extremely rapid decreases in greenhouse gas emissions in order to limit warming to 1.5 degrees C. And I think the scientific consensus is that we're more likely to breach 1.5 degrees C than not. And really, in many ways, the aim would be to overshoot the 1.5 degree target and then bring it back down. So I think it's probably not impossible that we will limit warming to 1.5 degrees C, but it's very difficult to see how that's going to happen given the very limited action we've seen to date.
So it does feel like quite an interesting time to be a climate scientist and watching all this play out, because I know that we are increasingly close to this 1.5 degree target, at which point climate risks start becoming larger and larger, and sometimes quite quickly. And so that feels difficult to cope with. Emissions are still high. At the same time, we've seen massive investment in low carbon energy and huge solar panels coming online in China. So it feels like we're balancing on a knife edge between the pessimism of watching emissions go up or not come down fast enough. And we know what's coming next, which is a huge revolution towards low carbon energy. What's your take on that? Are you optimistic or pessimistic that we can hit this target or at least minimize damage?
There are some grounds for optimism in the sense that we have the technologies available, but what we haven't seen is the action. I agree with you that we need these transitions towards renewable energy sources and a move away from fossil fuels. I think that's eminently achievable. Personally, I'd love to see that as soon as we possibly can. We know that, with every ton of CO2 that we emit, we're just exposing the world to more risks. So I think it is achievable. I think that regardless of whether we manage to limit warming to 1.5 C or not, we need to work as hard as we can, as quickly as we can, to bring emissions down, to limit whatever the future warming is. 1.5 C is not a magical number in any regard. It's much more a sliding scale. The more that we surpass 1.5 C, if indeed we do surpass it, the worse impacts we're going to see, basically. So there's everything to do. We have plenty of agency as an international community to fix this problem. We know how to do it. It is really largely a political problem.
So my understanding, Matt, is that if we do hit what they call net zero, which is net zero anthropogenic emissions, so human emissions into the atmosphere. So that means that humans draw down as much as they put into the atmosphere, for example. And if we do hit that number, that essentially warming will stop, but that warming will stop where it's got to, and it won't start cooling again. So it stops, extremes in flooding and storms and heat waves and that kind of thing stop getting worse, except for, and this is your scientific expertise, I know, except for sea level rise, which continues because the world has already warmed above the threshold where you start to melt ice sheets and this kind of thing. And those ice sheets are still melting even if we get to 1.5 degrees. Can you talk about, the continuation of sea level rise and the impacts of that, what that means?
There are some aspects of climate change that won't stop when emissions reach zero. One of the most important ones of those, as you've said, is sea level rise, but it also applies to some extent to wider ocean climate change, because the oceans are really absorbing the vast majority of the excess energy that's being trapped in the system. So the heating of the system that comes from greenhouse gases in the atmosphere, the majority of that goes into the ocean. It takes centuries before we start to see that warming slow and eventually stop. And then the other point you mentioned was the ice sheets. So the ice sheets are very, very slow responders within the climate system. It takes a long time for them to come into balance with a warmer world, basically. In terms of what we call committed sea level rise, so that's sea level rise that's locked in due to greenhouse gas emissions, we're looking at much longer time scales of lock-in of order thousands of years. So there will still be things we need to adapt to, even when we limit temperature rise. It's really a question of what level it's at. Then, there will be these ongoing changes, sea level rise, that we will have to adapt to. And some other aspects of the system also have these much longer or much slower response to warming.
So, Matt, I know that our listeners can get a really good idea about how these things are changing by looking at the Met Office Climate Dashboard, which I know you've been heavily involved with. Could you explain what the Climate Dashboard is, what it shows, and what information that's going to give to people who are listening, and maybe its target audience of policymakers as well?
The dashboard is a really neat website, which really pulls together a whole different bunch of observational indicators of climate change. So that includes surface temperature, ocean heat content change, which is essentially an expression of total ocean warming. There are indicators based on the amount of sea ice. So we know that the high latitudes near the poles, there's a large degree of sea ice, which is quite important for all kinds of reasons, including ecosystems and the kind of health of the planet more broadly.
That definitely feels useful for understanding how people are impacted.
Obviously, what you get is, these long records to really see the context. I think increasingly giving context for the projections and where we're headed in the future, it's important to see where we've been.
And you can really see the signature of climate change sort of turn up in the numbers.
Yeah, so a very important point is that although we talk a lot about surface temperature rise, and that is the basis of the Paris Agreement temperature targets, such as 1.5 degrees C, that's not the be-all and end-all. There are many other facets. So people often talk about the glaciers melting in mountain areas, and that has implications for future water supplies. There's the sea level, which is actually built up of a bunch of different components, including the ocean warming, also the melting ice sheets that we've seen. So all of these things have real-world implications for impacts and the adaptation, in some cases, that we know that we're going to have to make as societies around the world.
Now, Matt, I know that you've been heavily involved in COP in Dubai. What are you expecting to see there? What do you hope to see in COP?
We'll be there with IPCC colleagues to talk to delegates and to host some events where we try and talk a bit about the science and have panel sessions and allow some of that discussion between the science and the policy. One of the things we'll be doing is talking specifically about the 1.5 degree target. We're talking about some annual updates to the IPC assessments of observed climate change to update that scientific assessment on a more regular basis. It's been an exceptional year for extreme events. We know that those extreme events will increase as warming increases, and it's important that we have a good handle on the current status of where we are with climate change to hopefully, feed into those climate negotiations and encourage everyone to take meaningful, positive action.
Well, that's 1.5 degrees C, what it is and why it's important. I'd like to thank Matt Palmer for his insights on this topic. Our producer today was Claire Nazir and our editor was Adrian Holloway. Thanks for listening to Weather Snap. I'm Dr. Doug McNeall.